All right, so last section of the mod. Before I start, wanted to say a couple things. First of all, remember that during times like on weekends, and I expect more questions to come in on the weekends because the project's coming up. On our channel, we have Ben Jacobson and Matt Spar who help answer questions over the weekends and during the evenings as well. So the best way to get a hold of them, I think, is if you just post your question in our class Slack channel and maybe tag them. Even if you don't tag them, they'll see it. But if you want to get like their attention, tagging them definitely helps. And also, if you're like working through something, and let's say it's like Monday again, and I see it on Monday, I can help continue whatever the issue is. So I think that's really important to know what your resources are, especially as we're starting the project soon. Also, with regards to the project, we will be using GitHub for the project, so just prepare for that. I will walk through setting up your GitHub for the project on Thursday. Let's see, what else? Yeah, anything else like project related in terms of like what are the deliverables and like what the procedures are going to be, I will talk about on Thursday as well. All right, so one last thing I wanted to mention. On Learn, you have this number of how much is completed. A good number to be by the end of the project. This is definitely an arbitrary number, so like you can use your own judgment based on like what labs are like. For example, if you've had coding experience before, maybe you didn't do many of the beginner labs, but I'd say a good number to get done is about 130 out of 159. So if you see that your number is below that, just know that a good place to be by the end of module 1 is 130. And that will also be something that I will be asking about during the project reviews, just so that we know that you're covering material. Cool. Any questions regarding this? Awesome. All right, let's get into web scraping. In Learn, for this section, the first half of the section, I will tell you, it is actually ported over from our software engineering program. So it gives a little bit more background as to how HTML and CSS work. So I'd say everything up till like an introduction to web scraping, I'm not really going to go through today. I'm just going to go through the like exactly what you need to know to web scrape. But I'd say like this is definitely something you can deprioritize, or if you really want to, but it's something that you can do if you really want to know how like HTML works. It might come in handy in like your capstone when you want to like build out a front end for your for whatever app. But for now, I'd say that you definitely don't have to. These are not like super important labs right now, but they're definitely fun. The activities are fun. You get to like do some fun like HTML things. I think you get to like color in your own rainbow or like move some cats around. So if you want to do that, feel free. But I would say for this section, definitely focus on the second half. And you don't really need to know much of the first half to understand this second half. So again, if you want to like find something to focus on, definitely is the second half from introduction to web scraping onwards. And a really, really good lab is the scraping concerts lab, which actually scrapes concerts from this website called Resident Advisor. Right now, because there aren't as many concerts happening, there's less data, but the idea of scraping is still the same. So as long as there are still events, I just checked, there are still events there. So if you can get those, you're good enough. I don't think you might get like 1,000 events, but you'll find something. And as long as you can get like multiple, you're good. But cool. On the topic of scraping, I think there's some terminology to start with. First is the document object model, the DOM. So the DOM provides an interface for programs to change the structure, style, and content of web pages, and blah, blah, blah. You can read this. This is all from the labs. So where you find the DOM of something is what I like to do. I think a good example is Wikipedia. And this was a Wikipedia that we were using. This was a page that we were using in the last study group. And how you find the DOM is you right click and you click inspect on Google Chrome. I believe for Windows is a little bit different, but you can just Google and find the shortcut to bring up the inspect. So what's pretty neat is Here you can basically see the HTML that makes up this web page. I don't know if anyone's ever played around with this before, but it's actually pretty funny. Like for example, let's see, you can sort of like temporarily edit HTML. Like for example, how you use this, there's this button up here on the top left of the console. If you click, you can hover and it will basically jump to whatever part of the HTML this particular part is. So for example, I want to know where, okay, this okay is. You see how this just automatically updated to where that okay is. And so you can open it, you'll see this okay. And I don't know if anyone's ever tried this before, but this is something that I learned how to do when I was like having my own blog in middle school. But you can sort of edit this and be like 200 not okay, angry face, and it'll update like that. You're not actually changing Wikipedia, but that's just like something that's fun to do, that you can sort of see where elements are on a page. And so navigating this is hard. You can see it's just a bunch of mumbo jumbo, but if you want to scrape something, really easy, like the easiest way to do it is to click this button up here, hover over what it is you want, and then find it directly like that. And I'll talk about more intricately how we're going to scrape the data. So the DOM basically includes all of this stuff. It includes all our HTML, head, body, and let's see, in head, body, yeah, it actually talks about it here. You can see here there's a head, which is part of the HTML, and body, which is what you're seeing on the page. This terminology is a little less important, but just know that when we're scraping a page, we're scraping from the body of a page. And within the body is just like all your elements, basically what you're seeing on a page. The library that we use for scraping is called Beautiful Soup. It is designed for quick scraping projects and lets you scrape through HTML elements. And I'll walk through an example of scraping. It's actually pretty similar to doing API calls, like when we were doing in the last section with JSON and APIs. So yeah. So the example I'm going to walk through is scraping books to scrape, which I had open already. And let's say I want to do a project about books that are just all the books on this website, and I want to just get their basic information first. Let's say I wanted to get their URL, like each book's individual page. I wanted to get their title, their price, and whether they were in stock. So this is our main goal. And we're going to do this entire study group. We're just going to focus on how do we get all this information for all 1,000 books on this page. So cool. The things that we have to import when we're doing web scraping are Beautiful Soup, and it's actually from BS4 because it's the 4th version of Beautiful Soup, and requests, as we're familiar with from last section. So let's import these libraries. And very similarly, we're doing a request.get. Request.get was exactly the same thing that we did for APIs. So we're going to do a request.get and do that on the website that we want to scrape. So I just copied over the URL from here, bookstoscrape.com, and I just assigned it to HTML page. So let me explain that first line first. Let's take a look at HTML page. So it's a response 200. So this is exactly the same as what we were talking about in JSON's API. They also have response codes. So as a reminder, 200 is, okay, I changed this earlier, but 200 means okay. So awesome. So this worked. And the thing is with Beautiful Soup makes it a little easier for us to read HTML by doing HTML page.content. So similarly to what we were doing before, you know how we were doing .text for APIs, we can do .content. You can see that this is all the HTML that was on the page. You can see that this is extremely difficult to read. I don't know what I'm looking at right now, honestly. But Beautiful Soup basically has a parser, HTML.parser, which is an argument that you pass through this Beautiful Soup function. And it basically makes it a little bit easier to read. So I did the content and then put it with the parser in Beautiful Soup, and let's take a look at what soup looks like. So it's a little bit neater. You can see that everything's like in its own line. It's not as messy as it was before. And if you want it even cleaner, there's a soup.prettify. So prettify is just a method, or actually no, it's an attribute of beautiful soup. And it just makes it a little bit neater. I think this website by itself was already pretty clean. So this doesn't make a huge difference, but usually if you have like a really messy HTML, the .prettify helps you like with the indents, and it just makes things a little bit cleaner to read. But very often we're not looking through this HTML over here. Maybe we're looking for a particular thing. Like let's say I want to look for, all right, tipping the velvet. Then this helps because I can just do like a Command F or a Control F and search like tipping the velvet, just to make sure that that's in here. But that's really the only reason we would like look at the soup through your Jupyter notebook. Most of the time we're actually referring to the inspect here to find out what we want to scrape. So, all right, so now we have this messy soup here. And what we're going to do, how scraping works, is we're going to do find all and find in this soup. We're just going to use two main methods, find all and find, to pick out exactly what we need for our data set. So as I mentioned before, what we're trying to do here is we're trying to create a data set that has all of these books, has the number of stars, the title, the price, and whether it's in stock. So that's the data that we want to get from this website. So unfortunately, they don't have an API, so we're going to scrape this data. So let's see what I started with here. All right, so usually when I have something that is like kind of item by item, what I want to do is first find an element that will encase all the items I want. So for example, what I want is something like this. I want to find something that encases for each item everything that I want. So in this case, whatever this orange thing is, this orange thing or this green thing. Let's go with this. Let's go with this green one. Yeah. Whatever this green thing is encompasses, let's go back to this, encompasses this image, it encompasses the stars, the title, the price, and whether it's in stock, which is exactly what we want. When you're hovering over things, you can see that there are many different like scales. So for example, if I like hover like here, it'll get me all of the items all together, but that can be a little bit messy. So we're going to focus on getting one item at a time. So let's see, let's start with this one. And the way we do the scraping or the finding of the specific thing is we click on this and it will highlight exactly what we're looking for. So right now, this really doesn't mean anything, but you can see it says li and the class equals to this like column XS6, column blah, 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 all these things. So this is actually the search term that we're going to use. And so we can sort of guess that each item belongs to one of these classes. Just by like collapsing and like opening these sections, you can sort of guess that, all right, each item is going to be encompassed in one of these classes with the same name. So here we're lucky that they all have the same name. And for most websites that have many items of the same type, you would expect them to have the same class name. So in that case, if we basically find all of the classes that have this name, we should be able to get each book that is on this page. So the syntax for this, and it's a little bit tricky because there are different ways to do a find all, but I think that this is the most foolproof way, is that you do soup.findAll, and then it's actually a tuple and a dictionary. So it's a tuple where the first argument is actually this first part, this li, which is short for line. And then you tell it which class it is. So you do a dictionary of class equals to, and I literally just copy and pasted this over. So find all will basically take all of the elements that it finds that matches this search term and returns you a list. Let's do that real quick. So now we see here, I just ran this, still a little bit messy, but you can sort of kind of see that like, all right, here we have like some icon stars. We have like some titles, sharp object sounds like a book. You can see in stock. And you can see like there's sort of the information that we want. So let's just save that to a variable and we'll inspect it some more. So I saved it to a variable called first 20, and I checked the length, and the length turns out to be 20. So that's a really good sign because I know that on this page there are 20 books, and that that find all got me 20 elements. So there's a pretty good chance that that each of these elements represents a book, which is great. So all right, let's take a look at this first one. So I'm assigning first the first element of this first 20 list to the variable first, and let's just take a look. All right, so this is not too long. You can sort of see there are many different things going on here, and it does take some time to get used to reading HTML. I like really only scraped for like 2 out of 5 of my projects, so like whenever I'm getting back into scraping, it does take me a while. But you can sort of see that the stuff that you want is in here, right? So for example, you have your star rating. It says 3, and you have like the icon stars over here. You can sort of see that there's the title, A Light in the Attic. You can find here that there's the product price, which is perfect. We wanted that as well. And you also have like in-stock availability, in stock. Awesome. And there's a little bit of extra information. There's that like add to basket button. As you can see here, there was that add to basket button that was also collected. And for those of you who don't know, href is usually a hyperlink. So one thing that I could also get is, let's say I want to get the individual link to get like the book's information. Like let's say I just wanted to get all the URLs to get to this page. I can get that in the hyperlink here. So the hyperlink would just be /catalog/this. So cool. Let's just save that information as well. So what we need to do now is we need to turn all of this mumbo jumbo HTML into something that we can use. So when I'm scraping, I usually like to save these as a dictionary because dictionaries are a little bit more flexible. And also you can preserve the relationship between the keys and the values. So before we do that, and just remember for this preliminary step, we want to turn all of this into a dictionary of like keys and values. So ideally I want like URL equals to this, star rating equals to 3, title is like A Light in the Attic, and in stock or not in stock. So when we have this more broad HTML that has a bunch of pieces of information that we want, usually what we do is we do a .find. And so in contrast to a find all, where find all gets you all of the elements that have that same class tag, .find is a little bit more specific because .find only returns you the first iteration of whatever it is you're searching for. So let's build this up. So let's see, the first one that I'm actually gonna try and pull out, since it's at the top, I'm gonna try and pull out this URL. And so I don't know how many of you are familiar with hrefs, but hrefs, they don't usually give you the entire URL. Usually you have a base URL, which in this case, the base URL is just bookstoscrape.com. And they give you like the / you would have to take this part that they give you, and the full URL would just be / and then that rest of the href part. And so that's usually how URLs work. That's usually how hrefs work, sorry. Cool, so let's start by trying to extract this. And so when you're trying to find something in HTML, usually the way I do is I try and look and see what greater than, less than signs it's between. Like what, like, I don't know what you call these, like what triangle brackets they're between. So here I can sort of see that this information is sort of in the A tag, and A tag is generally for HTMLs as well. So all right, we can see that it's in an A tag, and there's no like class name or anything. Let's start with that. And it seems that there are no other A tags, so it won't give us multiple results, as in there won't be multiple results that we have to sift through. So in that case, we can just do a find A. And so let's start with this first. So when I do a find A, it pulls out, so first, the variable first has all of this, right? And if I'm just finding A, it pulls out this exact information, which is awesome. You can see that it's definitely narrowed down a lot more. And what the thing is that we want exactly is this href part. And so this actually took me a little bit of trial and error to figure out what the syntax is. This is actually XML syntax. If anyone is familiar with XML, don't worry if XML doesn't mean anything to you, because it's an old data type that doesn't really come about much. But if you ever have something that says something equal to something, it kind of works like a dictionary where you feed it in square brackets. So I saw that it was href equals to this. So therefore, I sort of treat it as the dictionary's key and call href, and I get exactly what I want here. So we're gonna first, at least the way I usually do it is I'm gonna first try and find how, I'm gonna first try and extract all the little bits and pieces that I want, and then I'll put it all into one function. So all right, we got the href down, we've got the URL down, so that's good. Next, let's take a look at title. And let me just comment this out a little piece by, so we can do it piece by piece. So all right, with title, I found that title was in between these h3 tags. So therefore, I just do a dot find on h3. So dot find h3, cool. All right, so I see that h3 has the title over here. So perfect, we've managed to narrow it down. So actually what I first did is I saw title equals to a light in the attic. So I thought that immediately I could do title, right? But take a look at this. I ran into a key error where title couldn't be found. And so this was actually something that as I was creating this notebook, I figured out is, all right, let's take a look back at this again, is that the h3 tags actually wrap this a tag. And title is actually an attribute that's between the a tags. It gets kind of confusing, and it's really like something that you could trial and error. And so what I did was to see, like, out of curiosity, what happens if I do a find, because you can do a find on a find. What happens if I do a find A just to get rid of this h3 and just pull out the A within the h3? So it's kind of like nested HTML tags. So I picked out the A here, and perfect. So I got rid of the h3, I have the A that was within it, and then let's try this again to see if we can get the title. Awesome. So this is how I got the title out. Any questions so far?
Okay. Ish, I missed the beginning, so I just wanted to know how much I missed. I have been here for last 10, 12 minutes.
Right. Not too much. Not too much. I talked about like basically just introducing HTML and what the DOM is. But pretty much what you miss is probably like getting this full soup. But just watch the video when it comes out.
Okay. Yeah.
Yeah. The concepts are pretty similar.
Hmm.
All right. So, all right. I understand that what we're doing is completely different from what we've been doing this past 6 weeks. So no worries. Like scraping did take me a while to get used to as well. All right. So let's move on. We found the link, we found the title. Let's take a look at price now. So price, after looking at this snippet here, I found that the price was just right here, between this P tag with the class price color. So that's a pretty straightforward one. And so the same syntax as what I was doing with the find all, where it takes in a tuple with P and also a dictionary of what class it is. I do that. And then I see that, okay, I kind of need to clean this up. How do I get this inside information, right? How do I get this information that's between the P tags? And this actually took me a bit of trial and error as well. It's literally .text. So very similar to what we were doing with, we actually did see this when we were doing APIs, but if you ever have information that's in between the tags, so as you can see, tags have like an open and a close. So this is the open p tag, and in the open p tag, it tells it what attributes the tag has, and then it has this close tag. So if you have any information that's in between open and close tags, you'll do a .text or .content, depending on what it is. So here, we'll just take the .text, and awesome, we have the price in a clean format. And then finally, let's take a look at the in-stock, and in-stock also very similar to that. Let's take a look at the in-stock availability here. I think I took a look at this one. So in these p tags, I looked for the in-stock availability, and interestingly, it came out like this. And if I do a .text on this similarly, you can sort of see that the in-stock is kind of there, and we can clean this up a bit later. And I'll show you a method that I use to clean this kind of text up. So the words in-stock are there. There's just all these new line characters that are kind of like messing things up. So this is basically here, they probably made some new line characters so that the words have some space between them. All right, now this one is a little bit more complicated. This is the last thing that we're gonna do. We're gonna try and get the star rating of the books. So as you can see here, they don't really explicitly say the star rating. They don't explicitly say how many stars it is. It's not like in a number. It's really in the color of the stars, or how many are shaded yellow out of gray. And if we look at it specifically here, actually no, let's take a look at this one. You can see that they have 5 star icons, but it doesn't really differentiate which ones are yellow, which ones are gray. So you can't really tell what numbers there are there. But there's this P class that says star rating 3. And through looking at a few of the other ones, so let's take a look at verse 20. Let's take a look at maybe the 5th one. You can see that here it says star rating 1. So now it gets a little bit tricky, because what we want to do now, so that we can reuse this function over and over again, depending, regardless of what the star rating is, because the class names are going to be different. It's going to be star rating 1, star rating 2, 3, 4, and 5. We can't do something like class equals to star rating. I mean, we can, but that would be a little bit, that would just be a little bit more messy in the code. So we're going to introduce something called Regex. It is a mod 4 topic, so don't worry too much about it. But basically, Regex is a different language that's used to parse text. And so if you want to look for something like star rating 1, 2, 3, 4, 5, and you want it to account, you still want it to find star rating 1, 2, 3, 4, 5, regardless of what the number is, you can use something like Regex. And so Regex is something we don't have to worry about now, but just know that this string basically is looking for any string that includes star rating and whatever that comes after it. It's basically, think of it as like wildcard characters. So it's just looking for star rating, and it doesn't matter what comes after it, it will still find those classes. Does that make sense?
How different this is from the Lambda function?
Completely different. Lambda functions are to like repeat tasks for different things. Regex is a completely different language that it's more used for when we get to natural language processing in mod 4. But just know that what we're compiling here, this is in another language. So this is saying that we're looking for star rating. We're looking for a string that says star rating with whatever wildcard characters. So this like combination of like parentheses, full stop, and asterisks means wildcard characters. So it's basically going to look for any class that has star rating, whatever. So just know that this is what it is. And then you can use this regex in the find. So not super important to understand what's happening here. If you ever run into a scraping situation that needs regex, I will say that try not to get into that situation. But if you do, I will send over resources and I can walk you through how to do regex. But hopefully before mod 4, we won't need to. But basically, you can see that here in, when I run this, it picked out this P class that has the star rating 3. And it looks like we're having all this extra information, but what we want is an attribute of the P class, so we can still technically just pull out the star rating 3. For it to make sense, let me just run this next part. So I'm doing the first dot find with the P and the regex, and I'm just pulling out class. This class is here. And we can see that, oh, it turns out it's a list. It's actually star rating and 3. And so let's say I just want to keep 3. So we're just going to take, you can do either -1 or 1. And now I have 3. So now we have all of like the building blocks to create our full scraping function, to scrape all the information that we want from all these books on the page. Any questions before I move on? Cool, yeah. I can imagine a bunch of you are just like, what is happening right now? But yeah, I felt the same. But cool. So right now I'm gonna create a function that takes in the HTML for a single book. So the input to this function is a single book's HTML. And so we already created these individual find snippets that get you basically the building blocks of what we want. And so how this function works is I just started by instantiating an empty dictionary. And then I'm just like adding elements to the dictionary based on those find statements. So as you can see here, so I called the dictionary info. So I just instantiated a key title and assigned it to book.find. And I just copied over what I was doing here to find the title. So find H3, find A, index title. And that will basically assign whatever it is to title. Similarly for price, I remember for price, we have to do the .text. This one, for the in-stock availability, remember how in-stock availability gave us this like long, weird string with the new line characters? What I did was I used the string in method. So basically I basically checked to see if the substring in stock is in this find.text. And if it is, assign true, and if it isn't, assign false. Same for the stars. The stars I just copied and pasted the code over here. To be safer, actually, I should put the regex compile here, just so it's always in the function. And then finally, this one was the first one that we did, the URL. So what I did was, because the URL only gave us the later half of the URL, I just did a string concatenation where I just put together the base URL with the slash plus that. And then we're going to return info. We're going to return this dictionary. So let's take a look at how this runs on a single book. So clean scrape, actually, let's take a look at first. So first, remember, was this crazy looking HTML. And if I pass it through the clean scrape function, first, there we go. We can see that we took this and in a matter of like about half an hour, created a function that brought that crazy HTML to this clean dictionary of like keys and values where you have the title, price, in stock, stars, and the URL. Any questions?
All this was for only one book now, right?
Yeah, it's only for one book. It's only for one book. However, it's once you figure it out for one book, I'm going to show you right now, like the process for doing it for all books is very, very straightforward from here on out. Okay. So yeah, any other questions before I move on? All right, we already did a bulk of the work here. So what I'm doing here, this clean scrape function takes in one book's HTML and outputs this dictionary. And as we remember, if we want a data frame, the cleanest way to get our data into a data frame is if we have a list of dictionaries. And so remember what first 20 was? First 20 was that very first find all. So let's go back here. First 20 was this very first find all, where I went back to the books here and I found that like, all right, each of these like classes encompasses a book's information. So each element in this first 20 is the HTML of a book. See, this is number 5, this is number 8. Basically, we can just run the same function on each of the books. And so what I'm doing here, what I'm doing over here is I'm just doing a list comprehension, and I'm doing clean scrape book for book in first 20. So I'm just gonna loop over each book in first 20. I'm gonna loop through each book's HTML in first 20 and turn it into a dictionary. So that's what this does. And now, as you can see, I have a list of dictionaries. And so it took us a while to do it for one, but almost immediately we have it for 20 books. And as we know, we can turn this into a data frame just by wrapping the list of dictionaries into pd.dataframe. And awesome. So we have our data frame just like this. It will take a little bit more cleaning. For example, like this price was a string. So you just need to clean out this like euro sign and turn it back into a float. You might want to take this stars number and do like a dot replace, turning it into like the numbers 1, 2, 3, 4, 5. You might have to clean up null values. But I would say this is pretty clean based on like, we literally took this from this. All right, any questions here?
This web scraping can be done for any website or only those who allowed for scraping?
That's a great question. So most websites, yes, you can scrape. A lot of websites, some websites actually will block you if they find that you're scraping too much. So for example, once I was trying to scrape Reddit for, I forget what I was trying to scrape for Reddit, but instead of a response 200, so instead of giving me a response 200 like that, they gave me a different response, and I forget which one it was, but it was basically the one that they either gave me a 403 or I think they gave me a request timeout, because basically I wrote a scrape function that took too much data at once, and so therefore they blocked me, but only for like a couple hours, and then I realized that I can just request less data at a time. And I'm going to show you guys how to do that in a bit as well. Yeah, so if you're trying to scrape something and you see that they give you, sometimes they give you like funny, I know like some websites will give you funny responses, like they'll sort of like troll you and be like, haha, I see what you're trying to do, but don't do it. But most websites will let you scrape. I know Amazon lets you scrape. Craigslist is a really good one for scraping. A lot of people like to use Craigslist data because it's really weird. But yeah, most websites that you would need that have like a lot of repetitive data should be okay to scrape. Yelp lets you scrape as well. Yeah, that's a good question. Cool. Anything else? All right. So as you can see, this website has, this website has 1,000 books, but I only managed to scrape the first 20. This part does depend website to website, but let's take a look at, let's say I want to get the next 20. And something that's good to take notice, let's take a look at this URL, because we're going to be scraping from different pages, right? And so let's take a look at what happens to this URL when I keep pressing next. So right now it says bookstoscrape.com catalog page2.html. If I click next again, page 3 HTML. I click next again, page 4 HTML. So this is actually one of the better scraping websites because all that's changing is the number over here. And I know there are 50 pages, which is awesome. So in a case like this, what I can do is I can do pagination, which is similar to what we were doing for the APIs with the offset. But instead now, I know that all I have to change is the URL. And just to double check, page 1 is sometimes an outlier. Like usually sometimes like page 1 is a little different because the original one that we were looking at, the original, the original URL didn't have any /catalog/ whatever. Let's just check if page 1 gives us page 1. And turns out it does. So page 1 does give us back page 1, so it's a little bit easier for us. So this part, there are different ways that you can do it, but the way I like to do it is first I just create a list of URLs that I want. So this is the first URL. I just made sure that that worked. Now I'm just going to create a list of URLs that has page 1 through 50. And here I'm doing a string dot format. I'm going to format for I in range 1 to 51. And if you remember, range just starts with the first number and ends the number right before the last number. So URLs basically gives me this list of URLs that has all the pages. Yeah. So here I'm going to do it in 2 steps. So first, I'm going to get the 20 books HTMLs from each of these pages and then run my cleaning function. So first I'm going to have to take, because each of these URLs, I'm going to get to this stuff. Each of these URLs, I'm going to get a soup. I need to run a find all to create this. Let's see, I need to get this for each URL. And then I need to clean that up. So let's take a look at this. What I did here in this get 20 books, I found the HTML page using the request.get. I throw it in the HTML parser. I did the soup.findAll, and I know that the find all comes into the raw. I assigned the soup.findAll to the variable raw. And then I know that raw is basically 20 of this. And so I can just run my cleaning function there. So different people do this in different orders. Sometimes people like to keep all of the raw and then run their cleaning functions. But what I'm doing here is I'm just cleaning the functions for 20 books. And so here, this function just takes one of these URLs and spits out the 20 dictionaries. So let's just run this function on one single URL. Let's just take this one, page 47. Let's do get 20 books and page 47 here. Immediately, it just gives me really nicely and really clean the 20 dictionaries that I want. And you can sort of see that these are the books on page 47 because we haven't seen these yet. So I'm guessing these are page 47 books. So get 20 books I know can run on each of these URLs, and I have 50 of these. So what I'm doing now is I'm going to make a master list of dictionaries. And then for URL and URLs, I'm going to extend, not append, but extend. Does anyone remember the difference between append and extend? All right.
Does it have to do with mutation?
Not really, not exactly, but good. I like that you're thinking of mutation. So when you do a .append, you're appending the full thing as a single element of the list. But here, because get 20 books gives you back a list, right? It already gives you a list, and you're gonna get because you already have a list, and all you want to do is extend the list with more elements. So the difference being, let's take a look at this. I'm gonna run it with .append and see what happens. All right, so right now it's .extend. And it's going to take a while because it's running through 50 pages. Let's see. Yeah, it's taking a while because it's getting all the HTML for 1,000 books and putting it together. I hope it doesn't take too long. There we go. So here you can see I did a .extend, and .extend basically takes all the lists and puts them together in one list. So here you can see that I have, I'm going to demonstrate .append later after this, but you see I basically have a list with 1,000 dictionaries with all the books information. Awesome. And then I'm just going to quickly do a pd.data frame of all the dictionaries and take a look at this. We have now 1,000 books. And I remember like 8 minutes ago, we only had information for one book. And now we have information for 1,000 books. So it's really like, you're really front loading all the work when you're doing scraping, because you just need to figure it out for one thing, and then you can figure it out for all the other things. Any questions about this? Because I want to talk about .append really quick. All right. So the difference between .append and .extend is, let's change this to .append. And this is going to take a while to run again. But can anyone, before this runs, does anyone else maybe want to guess what the difference between append and extend is?
I'll guess that it has separate lists, 20 different lists.
Exactly, yeah.
Or sublists, yeah.
You're right. So when you're doing a .append, it appends each of these outputs as a nested list. So how do I phrase this properly? So as you can see, the length of all dics is 50, because I ran through 50 URLs, and then each one of them gave me a list of 20 and appended that full list of 20 as a single element to the list. So therefore, we actually have nested lists. So if we take a look at all dics index 0, it's a list of 20. It's a list of 20. And if we look at, I think if we look at like 26, it's also a list of 20. And so the difference between doing .append and .extend is you basically don't have these nested lists. Yeah, wow, this is a long output. But you can basically see here that it is nested here. There's one list here, and let's see if I can try and find the beginning of, there we go. So it's nested lists. So if you're doing a .append, it'll nest lists within lists, but if we do .extend, it'll just extend the list instead of adding new lists within the list. Cool. That's a pretty important distinction. .extend is actually pretty useful, especially when you're dealing with like chunks of data. All right, any questions about scraping? I know this is completely different from what we were doing before, but yeah, any questions?
Just one thing. Now, the append part and the extend part, how useful it will be for when we are pulling in all the data frames, I mean, data from different websites, and then we want to club it together to make one data frame.
So data frames don't have like a I think there's data frame .append, and data frame .append does, I think, just extend the data frame. But if you're starting off with a list of dictionaries, yeah, you will want to do .extend if you're getting lists of dictionaries at a time. If that makes sense.
But like, is it that like all the details of the dictionary or the keywords of the dictionary needs to be the same?
Good point. So let's say one of these dictionaries had an extra key. Maybe it took in like the image URL. What would happen is when you turn list of dictionaries, if one of the dictionaries has an extra key, it would actually make a new column. And then it will all be null values except for the one.
I mean,
So
that is for .extend. And
no, that is for any time you're turning a list of dictionaries into a data frame.
Okay.
Yeah, nothing to do. .extend and .append is just when you're adding data to a list. How do you want to add the data to a list? Are you appending like chunks of data to a list? Because if you append a chunk of data, it will have a nested, it would be nested as a single element. But if you do a .extend, it will be a part of the original list.
Okay.
Yeah, just like play around with it with different lists, and I think you'll sort of see what goes on. But yeah, I think important to reiterate, if there are no other questions, feel free to interrupt me if you have any more questions. But For this section, I'll say again, this first part, everything from the intro to like the My Little Rainbow Lab is ported over from the software engineering course. And so it gives like a very like pretty in-depth discussion of what HTML and CSS is, which for our purpose, like as you can see, like we didn't really need to know what all of that meant to Webscrape. So definitely would deprioritize that first part, and then only like the second half of the section is what's really important for our purposes. But I think it's also, I mean, these labs are actually more fun because you actually get to like play around with HTML and CSS elements. So if you have time, like during the project, if you're like done with working with your if you're like bored of working on your project, you can feel free and go and like play with these labs. But they are, just know that they are from the software engineering side because they do like work with HTML and CSS all the time. So less important for us, but it's always good to know. So in terms of like how you want to prioritize, up to you. Cool. Any final questions?
I have one, I guess, to just clarify with append and extend.
Yeah.
What would be a scenario which you would use append over extend? Because I know like extend, you're basically like pulling everything into one item. So I'm just trying to clarify the difference between the two and why you would use one over the other.
Absolutely. This output is really long, so let me collapse this. All right, so we're using .extend because each of these outputs is already a list. So let's say like I wrote this function differently such that each function, each output is a single dictionary. Then I would do .append of each dictionary to a master list. Does that help clarify?
Yeah. I guess like you're saying, we just need to play around with it and manipulate it and see what it does.
Yeah, for sure, definitely. Yeah, so you have to think about what your output for like the inner functions are, because here I'm using functions within functions. So I know that each of these gives me things in a list already, and so I would just need to extend this list with this result. But if this happened to give me just a single dictionary, I would then do a .append of this dictionary into the list because it's not already a list.
Okay, I gotcha.
Okay, yeah. This is something that, yeah, honestly, I didn't even know of .extend until like, unfortunately, like way after I graduated. So no worries. Like, because if you do a .append and you end up with nested lists, you would just have to like do other functions to put the list together, which can get a little bit tedious. So I think it's good to like get used, just know that both of these exist. But yeah, anything else?
I just wanted to know if anybody is interested in working in teams. Anybody has approached?
So I actually already told people who want to work in teams who their partners are. If anyone else reaches out, I'll let you know. Yeah. So yeah, if anyone else wants to work in a team, please send me a Slack and let me know, so I can like pair you up as soon as possible.
I'm in for it. So if somebody is wanting to work, then we can.
Yeah, I'm ready to work.
Awesome. Okay, I'll get you guys in a DM and then you can start talking.
Perfect.
Oh, okay.
Yeah.
All right. Any last questions? Cool. Awesome. As usual, anything, Slack me. On Thursdays, I think it's going to be pretty important because I'm going to be walking through how to set up your GitHub for your project, and I'm also going to be outlining all of the deliverables for the project. So hopefully that you can make it, just in case there are any questions, but if not, it'll also be recorded. But cool. In that case, have a good rest of your Monday, everybody, and I will see you all at your one-on-ones or on Thursday.
Thanks, Yash.
Bye.